So far, you've learned how to add, subtract, and multiply complex numbers, but now we're going to discuss how to divide complex numbers. And in order to do this, you need to have some vocab. We are going to be using complex conjugates. You've learned that a complex number is written in the form a plus bi. Remember, a is the real portion, and then bi is the imaginary. The complex conjugate would be a minus bi. So that doesn't mean that this is always going to be a plus sign and this is always going to be a minus sign. What it really means is there's going to be an opposite sign here in the b value. So if this was 1 plus I, its conjugate would be 1 minus I. If this was 1 minus I, the opposite would be 1 plus I. We're going to see that in the examples here as well. So starting with part A. When I see 2i minus 15, I notice that this is not written in standard form. So the first thing I'm actually going to have to do is write it in standard form. Write in standard form. Once you have it in standard form, then you would be able to find its conjugate for step 2. You don't want to do it right away because then you're going to be changing the sign of the wrong term. So once again, the first thing I have to do is write it in standard form. So the real number was negative 15, so I need to put the negative 15 first. And the imaginary part was the positive 2i, so I need to put plus 2i. To find its conjugate, all I have to do is change the sign right here with the imaginary part. So it becomes negative 15 minus 2i. That's my final answer. For part B, if I wanted to write it in standard form, the real number would come first, the imaginary second. Now there is no real number here, so I could substitute in a 0. So 0 minus 4i. To get its conjugate, I changed the sign, so 0 plus 4i. Writing it in the form helped me see which sign I would have to change, so I'm now going to simplify it all the way to a positive 4i. For part C, it already is in standard form. The 9 is the real number. The negative 1i is the imaginary part, so all I have to do is find its conjugate, which is 9 plus I. I'd like you to try part D. So go ahead and pause it and then hit play when you're ready. Remember, square root of 3 is a real number. If I were to plug it into my calculator, the square root of 3, I would get an actual numerical value. So this square root of 3 should be in the A position. It's listed first. And then the imaginary part was a positive 1i, so plus I would come second. Now that I have it written in standard form, I can find its conjugate by changing the sign, leaving me with the square root of 3 minus I. Now that we know what a complex conjugate is, we're going to go ahead and start dividing. Now this is probably the hardest part just because there's a lot of steps. So looking here, it says the key step here is to multiply the numerator and the denominator, just let me scooch it down, by the complex conjugate of the denominator. So we're using, I'm going to underline that, we are using the complex conjugate of the denominator. So my denominator is here, 1 minus 2i. I am multiplying the numerator and the denominator by its conjugate, and by it I mean the denominator. So the conjugate of 1 minus 2i is 1 plus 2i. So I need to write that on top and on the bottom. The reason why we have to do this is because technically we are multiplying by 1 because something over itself is 1, like 3 over 3 we would say is equal to 1. Negative 2 over negative 2 is 1. Something over itself is always 1, or we call this the fancy form of 1. So now I need to multiply across the top and across the bottom. So really it looks like this. I have 5 plus 3i times 1 plus 2i all over 1 minus 2i times 1 plus 2i. Okay? Now we need to, again, like I said, this is a lot of work. We need to FOIL the numerator and FOIL the denominator. Now, because we're using conjugates, you're going to see that the middle terms cancel out. I'll show you what I mean here. If I were to FOIL the denominator, 1 times 1 is 1. 1 times 2i is 2i. Negative 2i times 1 is a negative 2i. And then negative 2i times a positive 2i is a negative 4i squared. Okay? What I was mentioning before was the middle terms canceling out. Boom, boom. So whenever we're looking at the denominator, or again, whenever we multiply something by its conjugate, you essentially just have to multiply the first terms and the last terms. So I got 1 and negative 4i squared. Okay, I need to FOIL out the numerator. So 1 times 5 is 5. 5 times 2i is a 10i. 3i times 1 is 3i, and 3i times 2i is a positive 6i squared. Let's clean this up. Remember, wherever we see I squared, we're going to substitute in a negative 1. So really what I have here is 5. I'm going to combine my i's. So 5 plus 13i plus 6 times I squared, which is a negative 1, all over 1 minus 4 times I squared, which was a negative 1. Still cleaning it up, that gives me 5 plus 3i minus 6 over 1 plus 4. Let's clean it up again. I'm going to write my numerator in standard form. So I'm looking at the real numbers first. 5 minus 6 is a negative 1. And then my imaginary number, so plus 3i, over 1 plus 4, which is 5. We're so close to being done, guys. I know this is a lot. But I must write my final answer in standard form. So remember, that's a real number and then my imaginary number. So this is technically all being divided by 5, meaning I can rewrite it as negative 1 over 5 plus 3i over 5. So negative 1 over 5, scooching this over so you can see it, plus 3i over 5. Notice how negative 1/5 is a real number and 3i over 5 is my imaginary number. So we are finally all done with this first one. Okay? Let's do it all again. So the key to dividing is to multiply by its conjugate. So the 4i is technically, remember, 0 plus 4i. So its conjugate would be 0 minus 4i, which is just a negative 4i. So I'm going to multiply the numerator and the denominator by that negative 4i. Now, I'm not foiling now because it's just a number, an imaginary number, so I can just distribute. Really, this is a negative 5 minus 3i times negative 4i, 4i times negative 4i. So I'm going to distribute the negative 4i to each of the terms in the parentheses, and then just multiply it out in the denominator. If you wanted to write it as 0 minus 4i and FOIL it, that is fine. We're going to end up with the same answer. I was just trying to make it a little bit easier on you. So again, I'm FOILing. Negative 4i times a negative 5 is a positive 20i. Negative 4i times a negative 3i is a positive 12i squared, because I times I is I squared. In the denominator, I have 4 times negative 4, which is negative 16i times I, which is I squared. Substitute in a negative 1 wherever you see I squared. I'm going to scooch this over real quick. That gives me 20i plus 12 times negative 1 and negative 16 times negative 1. Remember, our goal is to eventually write it in standard form. So I'm going to put my real number first and my imaginary number second. So 12 times negative 1 is a negative 12. And then I have a positive 20i here. All over negative 16 times negative 1 is a positive 16. Not done yet. Remember, I need to put real and then imaginary. So I can break this up as negative 12 over 16 plus 20i over 16. And I know we're tempted to say, hey, we're done, but we're actually not. There's just one more step. Do you notice how these fractions can be simplified? So whenever we can simplify, we would like to. 12 and 16, those are both divisible by 4, so this becomes a negative 3/4. And 20 and 16, once again, both divisible by 4, so this is plus 5i over 4. Here's my real number, here's my imaginary. That is my final answer. Oops. Didn't realize you couldn't see it. Okay, so that's what your final answer should look like. I now would like for you to try this problem. So hit pause, and then when you're ready, you can resume the video. Hopefully that went okay for you. The conjugate, remember you multiply the numerator and denominator, so the conjugate was 1 plus I. You would distribute in the numerator and FOIL in the denominator. I ended up getting, and I'm going to scooch it over just so you can see all my work. I ended up getting a negative 1 plus I as my final answer.